In this module, we're going to look at significant figures, specifically the significant figures in measuring. When we measure in chemistry, we'll either measure with a graduated device, digital device, or we'll simply count the items that we have. So let's start with graduated devices. In chemistry, graduated devices can include rulers, graduated cylinders, burettes, pipettes, anything in which the demarcations of the measurements are done with lines on the physical device. The most common device we will use in chemistry is a graduated cylinder, so we will start with that. Remember, when we measure liquids, we always want to measure to the bottom of the meniscus. This graduated cylinder has no markings in the 100s position, so we're going to leave that alone. But if I look in the 10s position, I can see the meniscus is above the 10, but below the 20. So I know for certain that the value in the 10s place is 1. If I go to the next level of markings, I can see that the meniscus is above the 4, but below the 5. So I know for certain that the value in the 1s position is 4. All good values of scientific measurement will have some degree of estimation. So I want to estimate the value in the 10s position. If I look at the 10ths position, I can see that it is a little bit less than halfway, so I'm going to call it a 4. Someone else might call it a 5, someone else might call it a 3. That's why this is the area of estimation. But because we estimated this value, we cannot guess anything any smaller than that. So I should record my measurement as 14.4 milliliters. The 4 in the 10th position is called the uncertainty. So we'd say that this device has its uncertainty in the tenths. The uncertainty plus the two certain numbers gives us the sig fig. So this measurement value would have 3 significant figures. Let's try another one. If I look at this graduated cylinder, I can see that it does have markings of the 100s, and the value of the meniscus is above the 100 but below the 200, so the hundreds position is 1. Now I have to estimate because there are no more markings, and if I look at it, it looks like it's about a third of the way down, so I'm going to call the value in the tens position a 3. And because that's my uncertainty, that's where I have to stop. I can write no other numbers. But on my screen I have a 13, and a 13 and 130 aren't equal to each other, so I need to find some way to indicate the magnitude of the measurement. And for that, I'm going to use scientific notation. So my value that's around 130, I'm going to call 1.3 times 10 to the second milliliters. In this case, the last written digit, the 3, is my uncertainty. But scientific notation can sometimes be unwieldy, so there is another convention. If I write 130 milliliters and I do not write the decimal point, if the decimal point is not written, that implies that all the zeros to the left of the decimal point are placeholders only, and the first non-zero digit, or the non-zero digit in the smallest decimal position, is my uncertainty. If I were to write the decimal point, that means that the last digit written, even if it is a 0, is the uncertainty, and that's going to change the number of sig figs. So to correctly write this, I would write it either 1.3 times 10 to the second or 130 with no decimal point. Both of these indicate that the uncertainty is in the tens position, and there are 2 significant figures. So let's try a couple of these on your own. In addition to graduate devices, we can do the same measuring with digital devices, only this is a lot easier. On a digital device, all the numbers are given for us. So on a digital device, the last digit that is displayed on the screen is the uncertainty. All the other digits are certain. So if I look at this device, the uncertainty is in the hundredths position. Now, every digit on the screen is going to be significant then. So if I count the digits on here, there are 5 significant figures. The last thing we could measure are counted items. If I look at the picture, I can see that there are 4 beakers. And I don't think there's 4 1/4 or 4.2 beakers on here. I know for sure that there are 4 beakers. Because of that, we say there is no uncertainty. And if there is no uncertainty in counted numbers, then sig figs do not apply. Or we could say there are infinite sig figs or there are unlimited sig figs, but I prefer to say they do not apply. We'll talk about that when we get into math later. That ends the segment on how to determine sig figs through measurements.